Hello, we try to solve this example or exercise 3.6 from your homework sheet. So the diagram shows three forces pulling at a link O, and we have 10 newtons is going away from the horizontal line by 45 degrees in that direction upward, and the 60 degrees or the 15 newtons going 60 degrees from the horizontal line south, and the other one going to the west north, or which the direction the 30 degrees, and as shown here. So in this question wants you to show the vertical components of the three forces acting through O. So we need to sketch the vertical. So the vertical will be that direction going upwards and downwards. So each force of these we can find the vertical components for it. So we start with the 10 newtons. So first we try to sketch that. So the vertical components for this one is going upwards, which should be relevant to that height, and that's, let's give it a color green, and we make sure that this will be matching this point and just make it as disconnected line. So this is the vertical for it, and to write it in terms of the angle, so this one will be, let's say, 10, and because we're going away from the angle, so it will be sine, and the angle is 45. Just go to insert equations and add the degrees. The other vertical, which is the 5 newtons, it's going here. So what I prefer to do first is to sketch the disconnected line to see where this will stop. So it's around this point, and then I'm converted to disconnected line, and then I sketch the arrow from here, and I will choose for example orange, and I will write the value for this 5 newtons would be 5 sine, and the angle would be 30 degrees. Insert equations, choose degrees. So this is the vertical for that one. The other 15 newtons, the vertical components for it is going downwards because the arrow is showing me that this is going south. Therefore, I will try to match that. First of all, you need to just try to sketch a line like that to give me where I can stop in my vertical, and then an arrow in that direction. I will stop till here. I will choose the blue arrow so to write it. Now we need to write down the equation or whatever will be the outcome for it. So that will be 15 sine 60 degrees. I'll just add the degree symbol to make sure when we solve it we don't have it in radians, because we definitely will get different answers. So to answer the first part, show the vertical components of the three forces acting through O. So we got the first one is 10 sine 45 degrees because we're going away from that. The other one is 5 sine 30 because that's the level of it. And the last one, which is 15 sine 60 degrees. To make it easy for you guys to know why we're using sine, if I'm going away from the angle, I will always use sine. If I'm going towards the angle in that direction, I will use the cosine. So the same thing we can do, calculate the magnitude of all components. Therefore, I need to finish this by determining the horizontal components. So again, I will sketch just those disconnected lines to indicate for me where I will stop in my angle. So that will be giving me the first one is here, and again we're choosing the green color, so that will represent for me the 10, as we say earlier, will be 10 cosine 45 degrees, and then I will just enter the degree sample for it. Now the other one for this 15 should be stopping around this point, so that will be the 15, so I will use the blue color for it, so that should stop here, and then make sure to use the blue, and that will be the value for it is 15 cosine 60 degrees. Right? So that's the component for this one. I will make sure to have these in different colors. So I will make this one to be a blue, so all of you will know the components. And this one was green, so I would choose dark green to make sure you guys, or something really darker than that, so you can understand what we're doing. Oh, that's not really what we're looking for. Let's choose this one, and this one will be the dark green as well. Now the only thing left to me is to find that component, so I will just sketch the disconnected line to know where should be my components force will stop. So I will come in that direction and that horizontal, and remember we're choosing the orange, so I will use that one, and the force for this one will be 5 cosine 30 degrees. Insert the sample for the degrees. Alright, so in this way I will make sure this is orange so you can know what we're doing and when we see it in the code. So this is the 5 sine 30 degrees for the horizontal, for the vertical, and this one is 5 cosine 30 for the horizontal components. Now part B, calculate the magnitude of all the components. So very easy. Since you have your calculator, so it's just we need to determine the value for it. So make sure you're using your own calculator and set it up to degrees. So the first one is 45. So cosine or sine 45 times 10. That will give you 7.07 newtons. And because it's the same applied here, if you try using your calculator, will be cosine 45 is equal to sine 45 degrees, so it gives you 7.07 newtons. Now if we try to find the value for this one is equal, so we'll have cosine 60 times 15, which will give you 7.5 newtons. And this one, forgot to convert it to blue, so to make sure like everything there. So this, if we solve it, we just say sine 60 times 15 will give you 12.99 newtons. I mean, you can still write it 30 newtons, but I'm just keeping it in the easy way. Okay, so that's the component for this one. And if I try to solve this one, so sine 30 times 5, that will give you 2.5 newtons for that value. And this one will give you, if we use cosine 30 times 5, will give you 4.33 newtons. So to answer the part which we were discussing earlier, that's calculate the magnitude of all the components, I did calculate the magnitude for the vertical and the horizontal components. Now part C of this question, so if we answer here, write a new space here to answer part C of this question, C, and then we go to equations and we will discuss this. So he wants you to add all the horizontal components algebraically together. So we will use the equation editor and then we introduce this one. Sorry, I did put it in the wrong place. So here we come here and then we go insert and then we introduce the algebraic summation for, we starting first with the horizontal. Capital H represent all horizontal components. So the first horizontal components we have, it's 7.07 in that direction, positive, if I'm assuming that's the positive direction, plus 7.5, which also is positive. So the green and the blue are going in that direction, which represent for me positive, I assume that. Against what we have that one, which I forgot to put the equal, and that's point here, against that will be minus the 4.33 newtons. If you solve that, the answer will be giving you 10.241 newtons. So that's the answer for part C. Now, part D, find the vertical components. So we try to solve same thing, but we're only considering the vertical components. So if I go again and introduce the equations we're trying to use, so I'll use this one. I'll type capital V, which represent vertical forces. So I got the vertical. If I start or assuming that anything going upward, it's positive, so that will be plus positive 7.07. Now something is also going up is plus the 2.5 newtons, this one, minus, because this blue one is going downwards, so 12.99 is in the negative. If I solve this, will give me a negative answer, 3.419 newtons, and it's mean this, it's representing for me that the vertical components is going downwards because the 12.99 newtons is bigger than the combination of 7.07 and 2.5. Therefore, this will be the answer for part D. So if we try to summarize the solution for this question, first of all, we have three different forces with their own angles. We try to find the components of each of the force. So first we determine the vertical components. So the vertical one for the 10 newtons is 10 sine 45, and then we calculate that value. And then for the 15 newtons is 15 sine 60 degrees, and then we calculated that value. And then the other one is 5 sine 30 degrees, which is equal to 2.5 newtons. And then we determine the horizontal values or components for each force. So for the 10 newtons will be 10 cosine 45 is equal to 7.07 newtons. And for the 15 newtons, because I'm moving towards that direction, so it will be 15 cosine 60 degrees equals to 7.5 newtons. And then the other one's going in that direction, which is 5 towards the angle. We'll be using cosine 30 degrees equal 4.33 newtons. After that, we have been asked to find the horizontal components and adding them together, but with respect to their direction, because we're using algebraic methods. So algebraic of horizontal forces is equal 7.07, this one, the green, plus 7.5, the blue one, for the 15 newtons, minus the 4.33 newtons going against them. So we have the blue and the green going in that direction and the orange one going the opposite direction. Therefore we need to subtract. And then you add them and subtract, you get 10.241 newtons. The last part of this question is to add all the vertical components algebraically together. So we have the 7.07 newtons upwards plus 2.5 newtons upwards. So any forces are in the same direction, you add. Opposite direction, you subtract. Therefore, minus 12.99, and that will give you the negative answer because the 12.99 number is bigger even than you add these two numbers together. Therefore, you get minus 3.419 newtons. That's the final answer for this question. I hope you enjoyed this video and hope you see another videos regarding this topic. See ya!